Welcome to Next Gen Manufacturing. Today, we are diving into a material that is, well, just about everywhere, from high-tech aerospace parts to the sink in your kitchen. I'm talking about stainless steel. It's incredibly useful, but if you're a machinist, you know it has a reputation for being an absolute nightmare. The good news? It really doesn't have to be. We're going to show you how a smart, systematic approach can turn this challenge into a total win. So here's how we're going to break it down in this explainer. First, we'll get to know the enemy. Why is stainless so tough? We're calling this the end mill assassin. Then we'll get smart about the 5 families of steel you gotta know. After that, it's all about solutions, picking the right tool, dialing in your parameters perfectly, and then putting it all together for what we call next-gen machining mastery.
All right, first things first, you can't win the battle if you don't understand what you're up against. And believe me, in the world of machining, stainless steel is a worthy opponent.
I just love this quote because, yeah, it's dramatic, but honestly, it's not wrong. End mills, the cutting tools doing all the hard work, they get eaten alive by stainless steel. It wears them down, snaps them in half, and just generally causes major headaches. So why? What makes it such an assassin? Well, the secret is right here. The magic ingredient that makes stainless steel stainless, that beautiful, shiny, rust-proof quality we want, is chromium. But here's the catch. That exact same chromium content makes the material tough, gummy, and super difficult to get a clean cut on. So the very thing that makes it so valuable is also what makes it such a pain to machine. So the first move in taming this beast is to realize that stainless steel isn't just one single thing, not at all. To really succeed, you have to know exactly which one of its 5, that's right, 5 families you're actually working with. And this breaks it down perfectly. You've got Austenitic, that's probably the most common one. You see it in food equipment. Then there's something totally different like Martensitic, which is hard enough for knives and surgical tools. And check out Precipitation-Hardened, or pH steel. That's the top dog, the strongest of the bunch, used for critical aerospace parts. Every single one has different properties, which means every single one needs a different game plan.
Okay, so you've identified your material. Now it's time to pick your weapon. Having the right tool is absolutely critical, and the right tool depends completely on the job you're trying to do.
We're going to focus on 4 main jobs here. You've got roughing, that's for hogging out a lot of material fast, slotting for cutting a channel or groove, finishing for getting that perfect smooth surface, and last but not least, a really cool next-gen technique called high-efficiency milling. Let's look at the best tool for each one.
For old-school roughing, you want to be aggressive. Think of the flutes on an end mill like they're teeth. A 5-flute tool has more teeth taking a bite out of the material, which means you can feed the machine faster and get that metal out of there in a hurry.
Now, for slotting, things get interesting. You'd think more flutes is always better, right? Nope. When you're cutting a deep groove, your #1 enemy is the chips you're creating. A tool with fewer flutes, like a 4-flute, has more open space for those chips to escape. If they get clogged up, your tool is toast. So here, chip evacuation is absolutely everything. And then there's finishing. The goal here is to get a beautiful, mirror-like surface. And for that, you want to go the other way. You want a high flute count, anywhere from 5 all the way up to 14. More flutes mean each tooth takes a much smaller, more delicate bite. And that's what gives you that pristine finish everyone's looking for.
Okay, now we're diving into the really next-gen stuff. High-efficiency milling, or HEM, isn't just about a tool, it's a whole different strategy. Instead of taking one big, heavy cut, you use sophisticated tool paths to take lighter, much faster cuts. This puts way less stress on the tool, which means you can run way faster and your tools last so much longer, even in something as nasty as stainless steel.
And this is where modern tool design is just awesome. Tools like this HEV5 are engineered from the ground up for these advanced techniques. It's like a Swiss Army knife. It's a beast at ham and finishing, but it can also hold its own in roughing and slotting. It's a perfect example of how the tools themselves are evolving for modern manufacturing.
So, you've figured out the steel. You've picked the perfect tool. You are almost there. But a fantastic tool is totally useless if you don't give it the right instructions. That's where your running parameters, your speeds and feeds, come into play.
As a general rule of thumb, your starting point for stainless steel is a surface feet per minute, or SFM, somewhere between 100 and 350. Just think of SFM as the speed limit for your tool. It's how fast the cutting edge is flying across the material. This range is your safe zone to get started. And hand in hand with speed is your chip load. That's just the thickness of the little chip that each flute carves off with every single rotation. And it's a really delicate balance. Go too heavy and you'll snap the tool. But go too light and you're not really cutting anymore, you're just rubbing. That creates a ton of heat, and that will absolutely destroy your end mill.
But here's the real next-gen leap forward. We've moved way beyond just looking at a generic chart on the wall. Today, we have data-driven tools that can calculate the absolute perfect, custom-tailored parameters for your exact setup, your tool, your grade of steel, your machine. This takes all the guesswork out of it and lets you really squeeze every ounce of performance out of your setup.
Okay, let's bring this all home. We've stared down the end mill assassin, we've learned its family secrets, we've picked our arsenal, and we've built our strategy. Now, it's time for the final step, mastery.
When you really boil it all down, it comes down to this clear three-step process. 1. Identify your material. 2. Select the right tool for that specific job. And 3. Optimize your running parameters using real data. That's it. That's the formula. So the most important thing to take away from all this is that success with a tough material like stainless steel isn't about luck. It's not about crossing your fingers and hoping for the best. It comes from knowledge. It comes from following a smart, systematic process every single time.
And that really brings us to the final question, one for you to think about. The tools are here, the strategies are here, the data is available. All of this represents a whole new level of precision and efficiency. So take a hard look at how you do things. Is it built on a solid, systematic foundation? Are your machining methods ready for the next generation?